Alright guys, welcome back to Explicit Tutorials. In today's video, we're going to talk about second order differential equation with constant coefficients. Now this is the one you'll be doing for this course. The square y over dx square plus b dy over dx plus c equals to d. Now for this level, you won't be a, b, c are not functions of x, they are just constants. That's why we said for constant coefficients. A, b, c are just constants, while d can be a constant or can be a function of x. Now there are several cases. Now if d was 0, for this video we're going to talk about d being 0. So let d be 0. In our next video, we'll talk about if d is not 0, how you solve the differential equation. Now, if b is 0, if d is 0, how do you solve this differential equation? Now, there's something we call auxiliary equation. The auxiliary equation is gotten from this. I won't be showing you guys the proof because of the pharmacy students watching this video, but I'll do a separate video for the proof of how these formulas were derived for the engineering students to watch. Now the auxiliary equation is gotten by these coefficients. Imagine this was a quadratic equation, am squared plus bm plus c equals 0. The coefficient of the second derivative is the coefficient of m squared. So imagine this was a quadratic equation. What will be your m? Using the quadratic formula, we'll have minus b plus or minus square root of b squared minus 4ac all over 2a. Now the solution to this differential equation is dependent on what you get from this. Now let's assume that after solving you get two values. Case 1, you get two values that are not the same. Let's call that value k1 and k2. You get, after solving this quadratic equation, you get two values that are not the same. Let's call it k1 and k2. Our solution to the differential equation will be your constant exponential k1x plus your another constant exponential k2x. As easy as that. Let's say you solve this is the first case where you have two different answers, exponential k1x and exponential k2x. Case 1. Case 2, let's say you solve, you get two different answers, but but these two answers are opposite of each other. Let's say plus 2 and minus 2. Plus 2 and minus 2 are two different answers, but they are opposite of each other. You can either leave your answer like this. Let's call that value k and minus k. You can either leave your answer as a exponential, since we said two different values, exponential kx plus b exponential minus kx. This one has two solutions. It's either you leave your answer like this or you leave your answer like this. y equals to a cos kx plus b sin ax. Not sine, hyperbolic cos and hyperbolic sine. So since we have k and minus k, is either you leave your answer like this, since there are two different values, or you leave your answer in this form. Now let's move over to case 3. Let's say you solve and you get one value twice. Let's say 2 and 2, 3 and 3. So let's say your answer is k. Your solution to that differential equation will not be a exponential kx plus b exponential kx. There's a reason for this, but I won't be showing you guys anything that has to do with the proof of all this in this video. I'll do a separate video for that. So your solution to the differential equation will be a times bx exponential kx. That's if you get just one value. Then the last case is if you get an imaginary value. Let's say you have u plus iv. This I is square root of minus 1. You have imaginary value. The solution to that differential equation will be a exponential, or rather sorry, exponential, this real part ux bracket a sine vx plus b cos vx. So this real part, exponential of the real part, then a sine the imaginary part. It doesn't matter whether there is minus sign here or not. It doesn't matter whether there is minus sign. If there was a minus sign here, this would have been minus v. If this minus v comes out, if the minus sign comes out, you still have a constant. So we have generalized everything. Then for cos, negative sign does not matter. You throw away the negative sign. So that will be all for all this case. We are going to solve 3 questions to explain all these cases. The first question I have here is 3y prime prime plus 4y prime minus 4y equals 0. Now let's solve this. The auxiliary equation is 3m squared plus 4m plus minus 4. It's possible in the equation you won't find minus 4y. It means that there's nothing here. You just equal it to 0. It's also possible in the equation that there's no y prime here. So you just do 3m squared minus 4 equals 0. So understand how it was gotten. So this is equal to 0. Now how do we solve? Remember that, remember our quadratic formula. So our m becomes minus b minus 4 plus or minus square root of b squared, that's 16, minus 4 times a, that's 12, times c minus c, that's plus 64 plus 48. 3 times this is 12, that's 48, yes. 16 plus 48 all over 2a, that's 6. So our m becomes minus 4 plus or minus square root of 64 all over 6. This is minus 4 plus or minus 8 all over 6. Minus 4 plus 8, that will give you plus 4. So that's 4 over 6, or minus 4 minus 8, that will give you minus 12. Divided by 2, you get minus 2. So it means that the solution to this differential equation, do not forget that this 4 over 6 can be reduced to 2 over 3. So the solution to this differential equation will be y is equals to a exponential 2 over 3x plus b exponential minus 2x. Let's assume after you solve that you got plus 2 and minus 2. What you simply do is a exponential 2x plus b exponential minus 2x. But I told you that for that case, you can also represent your answer in this form. So instead of writing it as a exponential 2x plus b exponential minus 2x, you can write it as a cos 2x plus b sin 2x. Now let's move over to the second question. The second question we have here is x dot dot minus 4x plus 4 equals 0. Now how do we get our x? The auxiliary equation is m squared, coefficient of, mind you, I told you in our introduction to differential equation that anytime you see dot dot, it is always with respect to time. So this is actually the square x over the t square. So even if it's p dot dot, what it means is the square p over the t square. So they can ask you y dot dot, they will test you and you put your answer in terms of x, you put y in terms of x, you have failed it. The option that y is in terms of t is the correct answer. So our auxiliary equation here is m squared minus 4m plus 4 equals 0. Now our m becomes minus b, that's minus 4, plus or minus square root of b squared, which is 16, minus 4 times ac, that's 16, all over 2a. So our m is 4 plus or minus 16 minus 16 is 0, so that part is out. So it means that we got we got 2 twice, and I said anytime you get one value twice, this becomes the general solution. So it means that x is equal to, don't forget that the dependent variable here is x, a plus bt, like I said, it is with respect to time, bt times exponential 2x. We are using this because we had just one value of x. Now let's solve our last question for this video and we'll be done with this video. We'll move over to the one of which d is not equal to 0. The last question for this video, we have x dx. Let me just put it in this form also. X dot dot plus x dot plus 1 equals 0. Now our auxiliary equation is m squared plus m plus 1 equals 0. Now what will be the value of m? This will be minus b plus or minus square root of b squared 1 minus 4a times c all over 2a. 4 times a, which is 4, times c, which is 1. So this is minus 1 plus or minus square root of minus 3 all over 2. So m is minus 1 over 2 plus or minus, if I bring this root 3 out, I will have minus 3 times minus 1 times 3. So the square root of this minus 1 is actually the I. Then we have square root of 3 all over 2. Now you can see that this is an imaginary, this led us to an imaginary form. And I said when we have imaginary, you separate it to this form, then it means that our general solution x in terms of t will be exponential, the real part, which is minus 1 over 2. So we have minus 1 over 2 t, then a sine the imaginary part, root 3 over 2 plus b cos root 3 over 2. And that will be all for this video. In our next video, we'll be talking about second order differential equation, where that d is a function of x. We'll be showing you different cases where you'll be able to solve for the general solution. Thanks for watching. Please do not forget to subscribe to our YouTube channel. Share this video to your friends, if possible your families. Share this video to anybody you know that needs differential equation. And do not forget, your comments are needed very much. Your comments are needed. Tell us how you feel about our videos. Tell us where we need to improve on our videos. Thanks for watching.